A stratovolcano that most people drive past without a second thought is sitting less than 100 miles from a major American city. And the truth about what it's capable of is far more unsettling than most residents realize. It isn't erupting right now. It isn't showing signs of an imminent blast. But the reason scientists watch this particular mountain more closely than almost any other volcano in the country has nothing to do with how likely it is to erupt, and everything to do with what happens the moment it does. If you want to understand exactly why this mountain is considered one of the most dangerous volcanoes in America, not because of lava, but because of something far more destructive, stick with me because I'm going to walk you through all of it. And if this is the kind of breakdown you find useful, go ahead and subscribe right now so you don't miss what happens next. Let's get into it. Let me start with the mountain itself, because its sheer size is part of what makes this story so serious. Standing at over 14,000 feet, it's the most heavily glaciated peak in the lower 48 states, wrapped in more than 25 glaciers and permanent snowfields that have built up over thousands of years. From a distance, it looks peaceful, almost postcard perfect, towering over the valleys and forests around it. But that beauty is deceptive, because underneath that thick blanket of ice sits an active volcano, one that geologists classify as a genuine long-term threat. Not because of how it might erupt, but because of what's sitting on top of it when it does. Here's the mechanism that makes this mountain so uniquely dangerous. And it's worth slowing down on this part because it's the entire heart of the story. Most people picture volcanic disaster as lava flowing down a slope, or ash raining from the sky. Those things can happen here too, but they're not the primary concern. The real threat is something called a lahar, a fast-moving slurry of volcanic debris, mud, rock, and melted ice that can travel down river valleys at speeds rivaling a car on the highway. When a volcano this heavily glaciated experiences even a moderate eruption, or in some cases just significant heat and shaking without a full eruption at all, it can rapidly melt huge volumes of snow and ice sitting on its slopes. That meltwater doesn't stay contained. It rushes downhill, picking up rock, ash, and loose sediment along the way, thickening into a wall of debris that behaves less like water and more like wet concrete in motion. And because this mountain sits at the head of several river valleys that flow directly into populated lowland areas, that debris flow has a clear, well-mapped path to travel straight toward communities that exist today, because those same valleys are fertile, flat, and convenient to build on. Now, here's where I want to be honest with you, because part of my job is telling you what the maps and models say, and part of it is telling you what actually keeps scientists up at night about this. A large lahar from this mountain doesn't require a massive, headline-grabbing eruption to happen. That's the detail most people miss. Even a relatively modest eruption, or in rare historical cases, no confirmed eruption at all, just a significant collapse of unstable, heat-weakened rock on the upper flanks, could be enough to trigger a lahar of serious size. That means the warning window between something starting and something reaching populated areas downstream could be alarmingly short. In some modeled scenarios, under an hour from the first signs of a major event to the flow reaching towns built in the valleys below. Let me walk you through why the towns downstream are positioned the way they are, because understanding this history helps explain the scale of what's being planned for today. Many of the communities sitting in these river valleys are built, in part, on top of ancient lahar deposits. The hardened remains of massive debris flows that occurred hundreds or even thousands of years ago, long before modern development. That's not a coincidence, and it's not reassuring. It means the ground those towns are built on has already demonstrated, repeatedly throughout geologic history, that it's a natural pathway for exactly this kind of event. One of the largest known events, a massive debris flow roughly 5,000 years ago, sent material all the way to what is now Puget Sound, covering an area now home to tens of thousands of people. Geologists didn't build the risk models around a worst-case hypothetical. They built them around something that has genuinely happened here before, more than once. So let me explain what's actually being done about this, because it isn't a story of scientists standing by helplessly. This mountain is one of the most heavily monitored volcanoes on the planet, wired with seismometers, GPS stations, and instruments designed to detect the earliest possible signs of unrest, subtle ground deformation, shifts in gas emissions, or swarms of small earthquakes beneath the surface. There's also a dedicated early warning system built specifically around the lahar threat, an acoustic flow monitoring network placed directly in the river valleys most at risk. These sensors are designed to detect the distinct low-frequency rumble of a debris flow the moment it begins moving, and automatically trigger alerts to emergency management systems and, ultimately, sirens in the communities downstream. The entire system exists because of one uncomfortable fact. When a lahar starts moving, there may not be time for a human to analyze the situation and manually issue a warning. The alert has to be near instant because the flow itself won't wait. I want to be careful here, because I'm not telling you an eruption is imminent, and nothing in current monitoring data suggests this mountain is gearing up for activity anytime soon. What I am telling you is that the infrastructure around this volcano exists precisely because the consequences of being unprepared are severe enough that waiting for clear signs of an eruption would already be too late for effective evacuation. This is a mountain being managed for a low probability, high consequence event, and that distinction matters enormously in how seriously it's treated. Let me pause here for a moment because I'm curious about something. Have you ever lived somewhere with a natural hazard hanging in the background, the kind of risk locals mostly don't think about day to day, but that occasionally resurfaces in conversation? Drop a comment and tell me what it was, because I think a lot of people live closer to these quiet risks than they realize. Now, let me widen the picture a bit, because this mountain isn't an isolated case. It's part of a chain of volcanoes stretching along the Pacific coast, formed by the same geological process, one tectonic plate sliding slowly beneath another, generating enough heat and pressure deep underground to fuel volcanic activity along the entire chain. Most of these volcanoes are quiet most of the time, which is part of why they're easy to underestimate. But quiet doesn't mean dormant, and dormant doesn't mean safe. Several of the volcanoes in this chain have erupted within the last few hundred years, some within living memory, and the geological forces that built this mountain range haven't gone anywhere. They're simply operating on a time scale that doesn't match the pace of human attention spans. That mismatch between geologic time and human patience is part of why long-term volcanic risk is so easy to file away and forget, right up until it isn't. Here's what I find genuinely striking about this particular mountain story. The danger isn't hypothetical in the way some disaster scenarios are. It isn't a matter of if the underlying conditions exist, they clearly do, sitting frozen in plain sight on the mountain's upper slopes every single day. It's a matter of when the right combination of heat, instability, and gravity lines up to set a lahar in motion, and how much warning time communities downstream will actually get when it happens. Scientists can't give you a date. Nobody can. But they can tell you the physical setup for a genuinely fast-moving, far-reaching disaster is sitting there right now, quietly, wrapped in ice, a short distance from where a lot of people live their ordinary lives. Before I wrap up, let me leave you with the practical picture, because a story like this only matters if it helps people understand real risk, rather than just feel unsettled by it. If you live in a river valley downstream of a glaciated volcano anywhere in this region, it's worth knowing whether you're inside a mapped lahar hazard zone. Most local emergency management offices publish these maps publicly, and knowing your nearest high ground and evacuation route in advance costs you nothing today and could matter enormously later. It's also worth understanding that the warning systems in place around mountains like this exist for exactly this reason, and taking a siren or an alert seriously in the moment, rather than waiting to see what happens, is precisely the behavior these systems are designed around. I also want to be straight with you about where the genuine uncertainty lies. Nobody can tell you when this mountain will erupt again, or whether the next significant event will be a small, contained one or something larger. What scientists can tell you with confidence is what the mountain is physically capable of, what's happened here before, and what the monitoring data would need to show before real concern is warranted. Right now, none of those warning signs are present. This is a story about long-term risk and long-term preparation, not an imminent threat. And I think that distinction is worth sitting with rather than glossing over. So before you go, I've got a question for you, and I'd love to see your answer in the comments. Does knowing a mountain like this exists change how you'd think about visiting the area? Or is this the kind of long odds risk that fades into the background of daily life pretty quickly? I read through the comments regularly, and it's genuinely interesting to see how people weigh risks like this differently, depending on where they live and what they've experienced before. That's going to do it for this breakdown. If you found this helpful, if it made a quiet, easy to overlook risk feel a little clearer, do me a quick favor and hit that like button, because it genuinely helps more people find these breakdowns when they need them. Subscribe if you haven't already, and turn on notifications so you're the first to know when the next one drops. And of course, drop your thoughts in the comments, because this community is one of the best parts of doing this.